All right, welcome back. And now we're going to talk about interpreting a graph, or a function rather, graphically. Okay, so again, I did my best to draw this graph, so my artistic skill notwithstanding. But we'll do this example. So this might be something you've been given along with some questions answered based on this graph. Okay. So the first question is, what is f of 2, right? So f of 2, so the way you do this is x is equal to 2. So we go to the graph, and when x is equal to 2, what's the value of the function f of x? So in other words, this is y versus x, but remember, y equals f of x. So f of x is on the y-axis. So f of 2 is the function evaluated at x equals 2, which is going to be 5. So that's going to be the answer to that one. Now, what about f of negative 5? Now, if we go to negative 5, we see that there's a hole in the graph, and so at x equals 5, this is undefined. Even though it looks like it's negative 3, there's a hole in the graph at 5, so this does not exist. Okay? So DNE is typically what we write for does not exist, or not defined. Okay? That's what this hole in the graph means. It's not defined at x equals 5. Okay? Now, what about this? F of x equals 0. So this is telling us what is the value of x when f of x is equal to 0. So where is this equal to 0? So the graph, when f of x is 0, that means it's crossing the x-axis. So it crosses here at 4, and it crosses here at negative 4. So that would mean that x equals plus or minus 4, based on the graph. Now, what about f of x equal to 3? Now we look at the graph, and we're looking for the value of the graph when f of x is at 3. So when f of x is at 3, which is right here, so that means all the values of x are from here to here. So that means that x is going to be from negative 3 to 1. Right? Okay, so that means we're looking at, hold on a second here. So negative 3, so we're including negative 3, comma, to 1. But we also have over here where f of x comes back to 3, so my graph is not, so right there. So when it comes back down to 3, x is equal to 3. So we would put union 3, something like that. Okay? Or we would say x is in a set of negative 3, comma 1, comma positive 3. That might work. Let me see how they wrote it. Right, now they have a slightly different answer, but I think because of their graph is different, but they did the same thing. So instead of a union, I'll just put a comma here. So I don't think it's exactly at 3, but I'm doing my best. Okay, now, what about the x-intercepts? Are there any x-intercepts, and what are they? Well, there might be 1 or 2 or 3. So let's look at x-intercepts. So where does it cross the x-intercept? So we found that the x-intercept is what? Plus or minus 4. Excuse me. So it's going to be what? It's going to be at -4, 0 and 4, 0. So those are your x-intercepts. Now what about the y-intercept? The y-intercept is going to be right here where it crosses the y-axis, and that's going to be at 0, 3. Now the domain of this function goes, the smallest value of x is going to be as small as -5, but it doesn't go to -5 because of the hole in the graph. So the domain is going to go from -5, but doesn't include -5, so I'm going to use a parenthesis, open parenthesis. And then it goes off to infinity because the arrow just keeps going down in that direction. So it's going to keep going to positive infinity. So that's the domain. The range, since it's going downward also, and it's going down to negative infinity, that's where we're going to start. So it goes from, negative infinity, and the highest it ever goes is 5. And so we're going to use a square bracket because it actually hits 5. And so that is how you interpret a function graphically.